morning to everyone and welcome to the IMARC METS Arena episode. I've lost count of how many episodes we've done, but holding this since June in collaboration obviously with Mining Plus as one of the technical sponsors for the event, as well as the Victorian government. This particular episode also is with the support of the GMG, which was part of the IMARC online program just last week. They put together a fantastic panel around the topic of battery electric vehicles. And today's conversation will continue on from that particular conversation with Brian Huff, Maarten, Ignacio, and also Gonzalo. So hopefully everyone watched part one of the particular discussion that took place as part of IMARC. We have shared that. And then today, these gents will continue on that particular conversation. With that said, we also have 4 METS companies joining us today from Safescape, from MacLean Engineering, from ABB, and from Siemens. And we'll hear from each of these 4 companies a little bit later on, with Michael Cockerill from Mining Plus hosting the Q&A with each of these guys. Now, just a quick note, you're all on mute at the moment. If you do have any questions to ask, you can either drop it into the chat box, which should be open for you to put any questions in there to me. I can then unmute you, so then you can ask that question at the end of any of the presentations, or otherwise at the end during our Q&A. Or otherwise, I'm happy to ask that question on your behalf as well to any of the speakers. Like I said, this particular series has been put together so we could combine both mining companies with particular problem statements or otherwise opportunities in the equipment, in the space of mining technology, and helping collaborate with METS companies that may have solutions for these particular problems or opportunities. And we have the technical advisor to be able to ask some particular technical questions so that we can really get to the bottom of what's going on in the industry in this sense as well. So without further ado, I'm going to pass over to our panel, which will be led by Ignacio from Buenaventura, who will speak with Gonzalo, who is from Codelco, Brian Huff from Artisan Vehicles, and Maarten from MacLean Engineering. So we've got a few different perspectives for this conversation. So Ignacio, I'll hand over to you.
Yes, hello, and thanks for inviting us for this second part. Thanks, Shireen, and thanks to my co-panelists, Gonzalo, Brian, and Maarten. If you haven't watched the video, we can still, we will pick it up from the last question that we asked for the panelists, which was how to convince top managers that BEVs or in general electrification is the way to go. And to summarize the answers that Brian and Maarten gave to us or shared with us, they mentioned that this is one of these rare cases that the technology is not only it's safe, is for production, is performance, is economically smart, and is environmentally good as well. So this technology is not new, perhaps it's new to mining, not anymore new. That was the perspective of the OEMs, Brian and Maarten. And Gonzalo mentioned more towards the collaboration that is needed to go forward. And he was inviting the OEMs to come closer to our continent, South America. So in that line, the first question I would like to ask to Gonzalo is, what are your perspectives? We know that you are opening this new Chuquicamata underground, which was open pit, now it's going underground. How are your perspectives in terms of going electric, and how are you doing this trade-off, this economic trade-off, CapEx, OpEx, going electric?
Yeah, well, thank you, Ignacio, for your question. And hello, everyone. Very happy to be here to share our experience from Codelco. Yeah, Chuquicamata Underground is a sort of new project. It's operating for already 1 year at the first level of production. It will have probably 3 levels of production. And it's actually a very good laboratory for us. So currently we are not operating with electric vehicles there, but we think it's actually a very good opportunity for 2 things. The first one is to try and test and pilot and and pioneer the development of tunnels and the construction of mine fully electric. So because we have plenty of kilometers of tunnel to build and construct during the next year. So that's a very nice challenge, and we think that actually the development of tunnels is probably the most interesting, one of the most interesting cases for electrifications, since our ventilation system is not really there. So we operate on ventilation systems that are not the definite ones. So we will have more gain in terms of health and safety on those works. So that's very interesting for Chuquicamata Underground in the upcoming years. And for the second level, which will start in operation around 2029, that's for sure full electrification. It's a technology that we are considering, definitely. It's already part of the trade-offs in the engineering phases, so it will definitely go that way for the second level.
Thanks, Gonzalo. In that same line, we have a mine, an underground gold mine, which will be opening hopefully 2 to 3 years from now, San Gabriel in south of Peru, gold mine. And now I have the question for Maarten and Brian, because we are already having many discussions, many meetings with the OEMs, and we feel that the support for countries like ours, Peru or Chile, and even Australia, these remote territories, is not the same as the one that you're having in North America and Europe, where you are basically co-developing the solutions in terms of size and specifications with the local mines. So the question for you is, what are the plans, to support mining companies in countries which are remote and that we like more support and clear, view on the scale up of production for our new mines?
You want to start, Maarten? Or?
Sure. As a starting point, we wouldn't sell equipment if we can't support it. MacLean has been, for example, very successful in Africa, in the Congo, based on our support that we offer equipment. So that's no different for electric vehicles. And that means investing in carrying inventory for parts, investing in training, having service technicians available to help you out that are factory trained. I don't think I'm not sure how that would be different from the mines that we service in Canada. We would have the same sort of support, whether it's South America, we have multiple branches there, or Australia, where we have multiple locations. So that's really no different. And I think a lot of it just starts with starting collaboration, starting to talk and make sure that we're all on the same page and what you want to achieve and how we can configure the machines to make sure that they perform as you expect. So I don't see that being very different from where we sold already. So
I'll pick up on what Maarten's saying there. We're being quite careful about where we go with this product offering, right? We're starting in North America, where it's close to our base of operations in their factory in California. And but Sandvik's already got infrastructure all over the world, and so we're building up the expertise for the local environments, building up the parts inventory in those areas, and it'll be kind of a staged release to make sure that, as Maarten said, you don't overreach, you don't put something out there that you can't support from the local infrastructure. But there is a couple technical advantages with this type of equipment. We touched on it a little bit last time, that these machines are highly computerized, mostly electronic controls, and that actually really enables remote support to happen more seamlessly than with other equipment. We can see pretty much everything we need to see to help diagnose your troubles completely online and remotely. We chat directly with technicians underground. They can ask questions, get answers 24 hours a day, 7 days a week, with real-time response. And and we can, you know, do remote control over their computers to do the diagnostics ourselves. And so it really enables technicians with minimal amount of training to perform the operations they need to maintain this equipment. It's a lot easier, I think, than something that's reliant so heavily on training up front. It does mean that you're somewhat dependent upon the OEM to provide that technical guidance and that diagnostics, but that changes over time, and that's going to be the same with any new technology, right? Over time, you get experience with it, the technicians are going to learn, and then eventually you won't need as much help from the OEM.
And on top of that, I think what gets me excited too is where I think we'll be going over the next couple of years is just increased levels of self-diagnostics on the machine. So that would make it even easier. I mean, we're starting to dabble into that a little bit, but I foresee that as a big growth area over the next couple of years to kind of offset some of those complexities as well.
Minimizes the growing pains on that for sure.
Yeah, exactly.
One other thing to add is, and we'll probably touch on this a little bit later, that this equipment is quite reliable from a primary component standpoint. You know, these motors and inverters last the life of the machine. They don't really have wearable parts, so you don't often see the same types of failures. Most of the issues we've seen are damage related. Things get broken, that happens all the time, and then figuring out what's broken, that can be a challenge. But it does relieve some of the day-to-day maintenance requirements and can make things a little easier on an operation.
Great. Yeah, so this is exactly how we are internally selling the acquisition, right, of electric equipment, because if you just look to the initial investment, it's quite high compared to the old diesel, but makes no sense to open a new mine thinking that you will operate diesel for the next 20 years, right? So we are really trying to convince with the technical people, the top management, to do, the total cost of ownership along the 20 years plus of life of the mine. But in that journey, what we are doing initially is taking the electric vehicles that we have, operated by cable, that the loaders, and we are, for the small ones, the really small ones, the two cubic yards, we are basically ourselves with a local supplier adapting a battery, right? But for the new ones, we would like to get the OEMs. I mean, we have all the local dealers here, but we feel that we would like more this co-development, so we can first go convert the cable ones to battery powered vehicles and then go further. And we have also the trolley solution, right? The diesel mixed with electric cables or wires there. So yeah, probably we can talk, or I don't know, Gonzalo or you, Brian, Maarten, more along the lines now of this CapEx and OpEx, because everybody talks about ventilation, but how does this work? Because we need to really think the new mine, the infrastructure of the new mine, totally different in terms of ventilation, in terms of charging stations, or more power, or basically we design the same as diesel and then we change equipment.
I'll take a stab at some of that. You're right. Like, there's a shift now. This equipment costs more upfront, currently anyway. We expect these costs to go down as volumes increase, and so we'll make this easier. But in the near term, the upfront cost is really offset by fuel costs down the road, as well as maintenance costs. Right? There's no midlife rebuild for the truck itself, at least for our equipment. There is a replacement cost for cells in the battery pack that age over time. They are essentially a new consumable, similar to filters or something else, right? Every time you use them, they age a little bit. They lose capacity. And so, typically on the order of once in the life of the machine, you'll have to replace the cells in the battery pack, which, for our case, it's roughly half the cost of the original price of the battery. But so essentially you're front loading some of your cost, but you're saving a lot in the long run versus fuel consumption and maintenance cost. So the total cost of ownership of the machine over its life is positive for sure for battery equipment. And then if upfront capital cost is a challenge, I know we offer, and some of the other OEMs offer, a similar battery program where you offer the battery as a service. That way the manufacturer owns the batteries and the charging systems, and you pay on a usage basis. That way it fits more into the economic model of a fuel powered equipment line, and that can kind of fit better with your business operation. So those kind of things are available to offset that. And of course, this is all going to change as the industry evolves.
I've just seen some questions come through. There's two important points here. One, Brian, there's a question for you on mentioning higher CapEx costs for EV. What percentage higher over diesel equipment do you think it is?
I'll get in trouble if I start giving prices online. But what I can say is that it comes out equivalent in the end. In fact, for our trucks, it's on the order of 10% lower total cost of ownership, but it is front loaded. And you can kind of imagine if you had to buy all of your diesel fuel for the life of a machine up front, that would add cost to it. But again, you don't have to do that, right? You can do a battery as a service or a lease program. There's many ways to kind of overcome that initial capital expenditure and get a model that's very similar to operating diesel equipment.
Yeah. An important point here from Naomi, which I think is relevant, is obviously both Ignacio and Gonzalo are speaking on behalf of the Latin American, North American market. I think electrification is something in Australia which is, you know, a real focus at the moment. Michael, I'm going to put you on the spot here, obviously being a colleague of Naomi's as well. And can you give us a quick, I guess, update on where you see electrification in Australia and the positioning it has here, and then I guess we can look at how it contrasts with both what Ignacio and Gonzalo were saying.
Yeah, sure. I think from a general standpoint, electrification is definitely the step forward for a lot of miners. We're seeing the likes of, I guess, Prominent Hill is a big example. Even the Newcrest of the world, they're all taking on board the likes of electrification and moving towards. Because obviously the electrification is a starting point for that automation process. So automation is really what people want to get to. It's a safer process. It's a more productive process, supposedly. It's got all these additional benefits on top of the electrification as what we've mentioned previously. So I think that as a standpoint opens up the door to the next level. So yeah, I think from not just Australia, but then you can look at sort of Europe as well. There's a lot of mines in Europe as well that are starting to head towards that. I'm sure Jonathan can mention a number of places that ABB is working with respect to the electrification and how that's really starting to open up more areas for the process. So I think from a North America and sort of Latin America, it's not just those areas. There's the whole world is looking at it. It's the next step for mining, and I think a lot of people are wanting to go in that direction. That's why we're all here today, I guess.
Yeah. Yes, Ignacio.
Yes, thank you, Michael. If I can add to that one, yes, electrification is one step towards automation, which everybody wants to go there. But there's a caveat there for South America, especially for the people that work on the Andes. We really look towards electric vehicles because of the high altitudes. Most of our mines are above 4,000 meters above sea level. That's more than 15,000 feet. And then the benefits of not losing power. I mean, we want to go electric as well because of this.
And I think you brought up a good point, Ignacio and Gonzalo, earlier about the remoteness. Obviously, Australia, a lot of our mines are quite remote as well. Gonzalo, Ignacio, are you finding that there are any other specific challenges that you guys as miners have in the installation development of electrification? And once you sort of answer that, we'll be able to kick off to the METS companies. Any particular challenges?
Well, yeah, sure. From our side, it's just a little introduction there. We Codelco, we have one of the biggest underground operation, and and we can have over 100 LHD working at the same time in our mine. So for instance, in El Teniente. So that's massive. And also other machines. We entered the mine by bus. We moved 12,000 workers a day to that mine. And we are going fully electric in all fronts. So our challenge is kind of special, and it has to do with scalability. It's not like the technology, we know that technology works, you know, it's already there for some years, and we've seen it working in Canada successfully, being developed also in the States. But our challenge is to do everything, you know, at the same time in a big level. So that's very our challenge, and therefore we need the full service here. So and it's there is no other way, and it's getting there. I mean, we have already conversation with OEMs here, and it's working, and we are partnering with some of them to pilot. But after the pilot, we need full service, and our plant is to be fully electric by 2030. So that's we want to get there, and we are not capable of doing it alone. So that's
Okay.
our main challenge.
Okay. Do you want to add anything, Ignacio? Otherwise, we'll kick off with the METS companies.
It's fine.
Okay.
Thank you.
Thank you. So we'll kick off with some of the METS companies who have joined us today, and just pointing out that obviously all these METS companies have been invited as they operate in Australia and have Australian offerings and solutions. Let's kick off first with Jonathan from ABB. Jonathan.
Oh, thanks. Are you going to slot the slide back now?
Yeah, that's right, we will.
Okay, so ABB has been obviously in the electrical game for quite a while, and we've been doing a lot of research into underground and above ground, basically completing the whole mine as an electrical package. You can move to the next slide if you don't mind. Okay, so basically we take, you know, all mines are electrified, and we've basically taken the position that we actually need to move this more and more underground, because that's where majority of your non-electrical applications are. So we've basically been doing a lot of development with the OEMs. We don't obviously do the batteries and the vehicles themselves, but we actually push forward for charging stations, the trolley assist systems, and that type of thing. So we've been really developing the charging units, how to actually get the vehicle up and running quicker. Because that's also the other state, you know, the vehicle can only run once the battery is charged. You have to also put it in the position that you know, how long is it down for when it's being charged. And there's two alternatives that you can actually look at doing, is replacing the battery and then leaving it on charge while it operates, so you're having a spare and a battery operating, or you have a fast charge. The only unfortunate thing with the fast charge, you can get it to about 85%. And then it's up and running. The replacement charge is looking at about 8 to 10 minutes, and the fast charge is looking at around about 20 minutes. The limitations, there's also limitations here as well. So we can build bigger and bigger charges, but it's whether the batteries can actually take that charge. And currently they're about 650 kilowatt. You know, putting it into the vehicle. The other things to consider with underground is when you go to battery or electric vehicle, is the huge reduction in ventilation costs. So ABB has looked at a lot of development in optimizing the ventilation systems, because that's probably in an underground mine up to 50% of its electrical costs. So there's significant gains to actually going this way as well, but also having the ability to control your ventilation systems. If you can go to the next slide. So here you actually see a system it's basically all electrified now, and we've got the ventilation systems, we've got the multiple charging stations. The important thing here to go to the next step is ABB has been involved with the SIM projects and looking at batteries for a number of years. The important thing is not just the vehicle itself, is actually managing the systems. Now, ABB has developed a number of scenarios or applications, and it's the OMS, Operation Management System, of this fleet underground. controlling the vehicle, knowing the vehicle's health, how long its task is actually needed to be performed, and when it needs to actually be charged, because a flat battery, or to get back to a charging station, you lose production time and everything else like that. So the key for these things is to understand their capabilities, then manage the schedule around them. And we've actually now developed schedules and systems that is real time, because you need to know currently where that vehicle is placed, how long it's doing its task for, and when it needs to actually be charged and get back to its task. So the operator, the sitting in the control room, the driver, the supervisor all needs to know these details so that the fleet can actually move around in that format. If you can go to the next one. Okay, so the above ground is similar. We've also, a lot of people are looking into this trolley assist, and we do it above ground and below ground, and we obviously have a number of platforms there. We also looking in this application is to store that on the descent is actually to store the energy that it's consuming, so that it can actually assist it back with the battery getting to the platforms. There's also AC drag lines and shovels that we're actually using the battery applications in swings and movements and that type of thing. And that really covers a lot of the battery. It's a quick overview. We only have a limited amount of time, so I try to make it as brief as possible. But essentially, our message is that everybody's going with battery-orientated vehicles. ABB is putting forward is not only those platforms as charging systems, the battery management systems, but also the operational side. How do we make the battery effective in these applications to keep production high and make sure that these platforms are being met and these systems are being met?
Thanks, Jonathan. Michael?
Yeah, thanks, Jonathan. Always interesting hearing what ABB is up to. I guess one of the aspects that is important for any mine, you've mentioned that a lot of people, or every mine does have electricity in it somewhere or somehow. Yep. But with respect to sort of going into this sort of a lot more focus in that electrical space, how difficult is it, and what sort of challenges do you face, especially in the underground or open pit area, with sort of implementing it properly?
Mm-hmm. The biggest thing with putting electrification down, I mean, there's already electricity down there because the guys need it for a certain amount of equipment. But obviously for batteries to be charged, you obviously have to have skids. So the implementation of the electrification side is not the bad. It's actually more the communication side, understanding, getting the feedback to the control room, to the operator, so that he knows the health of the vehicle, how it is, and also being managed on a schedule. I think you've got to have both. This is, as the guys mentioned with the OEMs, there's so much information on these vehicles at the moment. It's actually using that data correctly and actually managing the process correctly.
Yeah, for sure. So that sort of lends itself to the DCS systems that you guys have. And that's obviously plays a big role in sort of the management of all the systems, like your ventilation on demand, all your short network controls, etc. Do you have any comments on that side of things?
Yeah, absolutely. So I mean, it's now we're looking at, instead of your process and your mill being the process side, which has been the high automation side of your plant, now we are actually looking at the production area as being automated. So it's almost, running in an automated fashion is everybody knows what the next step is. They know where the vehicle has to be. They know how far it is in its task, how much it is charged. And that information then circulates. And that's how you can actually improve your productivity numbers, is actually understanding the different synergies between, your drillers, your blasters, your haulage information, so that everything works seamlessly. Because the biggest problem with underground is bottlenecks. And it's normally, because there's too much diesel, they haven't got enough ventilation, you're not performing correctly. So the nice thing about batteries and this type of information, you can actually get around these bottlenecks and actually, improve productivity significantly.
If it's okay, Michael, we might move on to the next METS company. And what I'm going to do is come back to some of these questions that have been submitted. The next one on our list is Max Ong from MacLean Engineering. Max.
Hello, everyone. Thanks for this opportunity to speak today. I'm very pleased to be speaking about battery electric vehicles as well as a diesel electric truck. both of which have been developed within MacLean Engineering and larger burn cut group in Australia. We are a tier 1 mining services contractor involved in the mining process itself, as well as the maintenance, refurbishment, overhaul, and ongoings of a lot of mining equipment. So I think it's important to share with you our position in the industry and how electric vehicles and electrical infrastructure affects what we do and how we do what we do. Because our focus is really to maximize our customers' return through very good services, value for money, and for that we have to place strategic investments in innovation and technology early up front to be competitive and get the edge to provide the best value. To do that, we have invested heavily in electrification, which is the theme of this session. And we come from the end of how do we do bulk haulage underground very effectively, minimal energy use, how do we prolong life of equipment and reduce costs all at the same time. And also we have people on the ground through our labor divisions that have to maintain these machines. So how do we maximize productivity? For a group of our size at MacLean Engineering, with these large facilities, we come from the angle that we've got the internal capability to improve the electrification process, from whether it's the vehicles to the infrastructure. And we started a long time ago on this step change because there just weren't any products or services available to achieve what we're trying to do out there. Next page, please. So in recent years, we've developed a battery electric four-wheel drive light vehicle specific for underground mining, which we believe is the most rigorous and harshest environment. So naturally, all of the developments transfer over to surface and road use as well. And I have to admit, we've been a bit late coming to the party with this technology, but for a very, very good reason. We believe in zero exhaust emissions, all about health, quality of life in underground working environment, and also fuel reduction. But the important enabler for that is ultra-fast recharging capability. So we've actually focused a lot of our time and effort, more than 2 years now, in battery development. We actually produce and assemble lithium titanate battery packs right here in Australia that we will be equipping into our light vehicles to start with. And that technology will scale up to future medium and heavy vehicles by actually being able to integrate the entire electric powertrain. We've done our numbers. We know there'll be significant OPEX savings in terms of elimination of commonly known wearable parts, mitigating failure. And of course, in the bigger picture, we understand ventilation costs, whether it's CapEx and ventilation systems or an ongoing energy costs as well. So we've begun with a well-established NCAP 5-star rated vehicle in order to align with road compliance and be able to mass produce that to bring the benefits to everyone. In that sense, we're committed to delivering the first vehicles in the second quarter of next year. But to be able to do that, we currently already every year produce 150 plus mine spec light vehicles, and we do fit them out to specific mining roles and site-specific requirements. So we understand that problem really well and engineer our solutions in there to bring CapEx and OPEX saving, because we ourselves own and operate a 400 plus mine spec light vehicle across our group of companies. So that all that experience and pain points and problem solving really goes into the solutions that we are providing. But the most important thing, I believe, generally for the industry is that not one piece of the puzzle can provide the enablers here. It's got to be a packaged solution. For example, infrastructure and fast chargers working together very well with the vehicle and the battery packs itself. And to achieve this, we've partnered up with Siemens, provide a mine spec very fast recharging stations. So to enable that as well on the back end, we are offering infrastructure upgrades, and again, in very innovative ways. For example, with numerous times now installed vertical cables installations that can provide the necessary power deep underground without actually disrupting day-to-day operations. which has seen a massive increase in productivity by eliminating downtime. For example, only 9 days to install a vertical cable, providing power to underground workshops and facilities within 9 days, and that's almost $1 million in saving in productivity without having to shut down access to the mine. So we're thinking holistic, big picture, and a comprehensive fleet of vehicles, and then scaling up to larger vehicles with very unique solutions.
Thanks, Max.
Next slide, please.
Oh.
Yeah. So this is my final slide, really. So coming from the bigger picture again, 5-6 years ago, as a group, we developed diesel electric truck to get early insight into what we can expect of heavy haulage electric vehicles. From there, we know that existing drivetrains are inefficient, maintenance intensive, and we've been able to pull higher productivity out of quicker cycles and better performance. So we're aiming for 20% productivity, whether it's Ultra or OEM, because we know what the performance benefits will be. We still have ongoing mine trials, so we've got better top speeds, quicker cycle times, things like that, and we understand the problem very, very well. So just a quick update on what we're doing next. We're looking at next-gen electric truck now, developed from the ground up. What are the possibilities? How do we optimize payload capacity, chassis functionality, weight, and energy efficiency? And there has been, as in the wider community, and many of you commented today, a shift towards more battery electric solutions, so that way we can maximize regen, supplement all systems, and also boost the manage the peak power demands to get the ideal and optimal solution out of electrification.
Thanks, Max. Michael, we might only have time for one question for Max. Yeah.
No, that's one quick one. So Max, you guys have a bit of a unique battery composition. So can you just comment on what kind of battery composition it is, and then I guess on the back end of it, how the safety, production, and environmental factors have played a role in getting to that point where you've made that selection?
Yeah, absolutely. All those factors you mentioned has been a driving force in what we do with the battery. From the ground up, we're actually producing our own lithium titanate battery packs, driven by mining safety regulations and compliance. Fire and smoke is a really bad situation to be in. So we're eliminating the root cause by selecting the optimum battery chemistry that will provide the amount of current, symmetrical charge and discharge capability. And in failure solutions, should that happen, whether it's contact or crush and penetration, will not produce the kind of catastrophic failures normally associated with such high density lithium packs. We're very confident of that, but behind that, battery management is very important, integrating the right safety interlocks, training and operation, and speccing that to the mine and its environment and operation is very, very important. Environmentally, we believe our battery packs actually, through analytical studies as well as really ruggedized and robust testing, high load cyclic environments, we know that the batteries will produce a longer life than what's already out there at the moment, comparing with phosphates or NMCs or aluminum-based and other lithium-ion chemistries. So with that long life, there is every opportunity to re-life vehicles, further improving your cost on the capital asset. And then also possibly in the longer term, further down the future, repackaging those cells and battery packs into set of fixed assets for energy storage across the entire mine, which will then leverage your renewables generation ability.
Might come back to you, Max. We've got some questions for you a little bit later on, but let's move on to our next METS company, if that's okay. We've got from Siemens, Olivia Laskowski, who's joining us.
Hi, everyone. So Siemens has been involved in mining for a long time. We also do the trolley assist system, which is typically for stretches of road that are not going to change too much, and really powering that truck when it's going up, and that power is going directly to motorize those wheels. In parallel to that, we're doing large haul electrification of long haul freight with our e-highway system, which is something that's also being looked at for mining as well. And this is more for direct high power charge of the battery while the vehicle is moving as well. And we're also involved in other areas that we know are being looked at across mines when miners are looking at that real full electrification. So we have our e-marine business, which looks at the onboard drivetrain and the charging infrastructure. And we know that some mining companies are looking at electrifying their tugboats in port. And then when we look at the trains, there are also provision of hydrogen trains, which is something else that is also looking, sort of into the future of a fully electrified mine. There's a snapshot of Siemens' portfolio. Now, some of these things probably look like they don't belong in a mine, and that's because most of, or all charging infrastructure has been really designed for public and light industrial applications. So Siemens have our C-Charge UC range, which is really for buses and trucks, and goes up from 125 to 800 kilowatts. So we can really support that high power charging. And it's backed by our EVC3 charging management software. So similar to what Jonathan was mentioning, this is really critical when it comes to managing an entire fleet where you want to be able to real-time monitor your charging infrastructure, be notified of the status of those charges. If there's any issues, that there's push notifications out by email or SMS to your fleet and maintenance team, but also that it integrates with the vehicle telematics. So you're getting that full picture of how the chargers work with the vehicles. And all of this is being driven really in the bus industry, because that's the fastest moving fleet to go electric globally. But it needs greater protection when you put it in the mining space. So if we go to the next slide, which is why we've partnered locally with Maher to develop a unit which I'm not allowed to currently show you, so that's why it's under wraps at the moment. But really we've done that because charging infrastructure, you want to get the maximum performance out of it. And that means it's designed for up to 15 years of life. So you want to maximize that investment in that infrastructure, and also you want it to perform at its highest performance. If you've invested it in a high power charger, you want it to be powering at the highest rate of charge. So the problem in a mining space, particularly in Australia, it's hot, it's dusty, if it's underground, it's high salinity, and all those factors will degrade the performance of your charger. So we worked with MacLean Engineering to design something that will protect the life of that asset and the performance of that asset. So most charging infrastructure will derate somewhere between 40 and 45. So always check that with your supplier, and it will shut down somewhere. Ours will go up to 55. And in a mining environment, those figures are not uncommon. So we worked with Maher to develop this fully sealed enclosure, so reticulated or recirculated air, I should say, and also so it protects it from a dusty environment. Charging infrastructure has quite high level of air intake, and you don't want to be replacing those filters every week to every month. Yeah, it's better if you're just protecting it and enclosing it fully and protecting it from that environment.
Awesome, thanks, Olivia. So one of the things that's obviously evident listening to your talk there is that there's a lot of industries that are going to the electrification side of things. So as we mentioned previously in this discussion, mining is a bit slow on the uptake when it comes to that. So how do we start improving that and getting that cross-industry intake from the other industries that have sort of perfected it, and then using that technology at a higher rate so we can start improving a little bit quicker as well?
Yeah, I mean, so buses are definitely leading the charge. I think they say 85% of buses globally by 2030 will be electric. So it's a high rate of uptake. Do I think anything in particular needs to be done differently for mining? You will see innovation to create a faster power charge than you need in the bus space. So that will definitely happen. But in the early stages where there's low hanging fruit, like your light vehicles across the mining space, there's nothing in particular you need to innovate for mining there. The charging infrastructure exists. It's more protecting it for that environment and then layering it with software so that it can talk to all the relevant platforms that you have. So your vehicle and potentially your grid infrastructure as well.
Sure. So I guess on the sort of grid infrastructure that you're talking about, renewable energies is really starting to pick up across the industry, and it's gotten to a point now where it's very competitive against normal electricity, coal-fired power stuff. But obviously, with the likes of solar or wind, it's very reliant on environmental factors. So does that play a factor with respect to the electrification? And how do you sort of say, we want to use renewable because it's great and it's user-friendly, but that fluctuation in the power it impacts the production rates and how we use it. So is there a way of implementing it with the electrification stuff that you're doing?
Yeah, well, if we take it back to the bus world again, where a lot has happened and trialled in this space, you do see battery storage playing a role in bus depots to store solar during the day and use it, because typically it's a different application. Buses typically charge overnight. So in a mining space, you're going to be charging all throughout the day. And in Australian mine in particular, given they're so productive, you'll be using daytime solar, and then you could have a level of redundancy in batteries that cover that nighttime. That's all an area that needs to be explored, I guess. And yeah, again, you can have sort of the microgrids will play a part there, and software is always part of this discussion.
We might move on to, thank you, Olivia, on to Steve from Safescape as our last METS company presenting, and get to the questions then. Thanks, Steve.
Thanks, Shereen. Just to provide a bit of context to the Bortana EV, Safescape has been delivering safety improvements to mines around the world for 10 years. Our latitude scapeways have been adopted across 22 countries, and there are more than 45 kilometres of fall arrest installed in mines that would not be there if it wasn't for Safescape. Our Edge Protector product improves safety for open pit mining operations while reducing stripping ratio and mining fleet emissions. Slide 2, please. The entire purpose behind Safescape developing the Bortana EV is to improve the safety and health environment on mines. To be effective at this, we have to get to the point of producing meaningful quantities of vehicles that have the highest possible safety standards and which have the lowest total cost of ownership. We believe we've achieved this by joining the ultimate in robust battery technology from 3ME Technology with a military off-road vehicle that has a galvanised cabin and a sealed chassis. The Bortana EV will survive in the underground mining environment better than any other road registerable EV. We've built one prototype and tested it over 18 months, including 6 months underground at several different sites in Australia. We're now building 10 beta phase testing vehicles, which will be supplied to a number of Australian mining operations in the first half of 2021. From there, we plan to begin continuous production in the second half of 2021, building to a rate of 50 vehicles per month by the end of 2022, provided that the demand exists. The Bortana EV utilises the body and chassis of the Agrale Marua, which is a Brazilian-built military vehicle that has a 5.7 tonne GVM. This platform was selected both due to its robust build and corrosion resistance, as well as the fact that it's produced to order on a conventional production line. That means for us, we receive the bodies that are built to our design, ready to receive our electric components. To be clear, this is not a retrofit. We're building EVs from the ground up using the bones of an existing diesel platform with the support of the OEM of that diesel platform. There's not enough time in this forum to explain the safety benefits of the blade bolt battery by 3ME, but it is our belief that this battery is the safest battery available for our application. Why is Safescape the right company to deliver the ultimate mining EV? Because we are of the mining industry. Our management team have owned mines, ran mines, managed mining contracting companies, and administered mining projects for major companies. We understand the challenges miners face, and when making decisions about our commercial offering, we maintain a focus on the application. For us, it's about keeping things safe and simple. Thank you.
Great, thanks, Steve. Yeah, I still remember the first time I had this chat with you and you mentioned about the 0 to 60 on this thing, and it just blew my mind. I can't remember what it was immediately, but it was bloody quick, and for something that size, it's pretty impressive. But I guess to get to that point, it's taken a lot of time and a lot of effort. And I mean, what were the biggest challenges that you faced with getting to that position where now you believe that you are the best for this operation?
Look, whether we're the best or not, I think that our vehicle is suited as the heavy use case vehicle. We've designed it because it's got a 2-ton payload. It will last a long time. That's the approach that we've taken. You know, there's a lot of other approaches that you can take. There are so many decisions that you need to make when you're building an electric light vehicle. And the reality is we actually don't know which of those decisions are the important decisions. So really for us, the critical piece of this is just to get these things into mines and have people learn. Like we learn, the OEMs learn, you know, maintenance teams learn, mining customers learn. It's all just about getting it into the mines, and that's the challenge, because the technical piece is doable, right? I mean, the technology exists.
Yep. Yeah. So one of the other things as well is the battery life is obviously an important factor of any EV. With respect to sort of the recycling of those batteries and making use of them after the battery is finished, or dead for that matter, whatever you want to call it, what happens after that? It might be a question for the panel in general, but do you know that?
Look, I mean, again, it's going to vary depending on the type of cell that you're using and the way that you use those cells in the battery in terms of, you know, how you can actually go ahead and reuse it. Some of these cells, like the Titan ones, are pretty amazing. Some of the NMC cells are amazing. You know, they're lasting for 10 to 30 years in a normal use cycle situation. So, and when we say lasting that long, that's rated, so that they've still got 80% of their capacity at the end of that life. There are so many applications they could be used for going forward. So it is actually a really important question about how cells are packaged in batteries, how they might be reused, but just too many options in the future. Yep.
Yes. So I mean, is it a point where once it's the usable life of it in a vehicle, it becomes irrelevant, but it still has some sort of life in it? Is that correct? So that you can actually use it for different applications and sort of in different industries or something?
Yeah, well, absolutely. So to give you an example, I think Max touched on it before, but some of these cells that we're using in batteries in order to achieve safety levels that we're aiming for, they're going to outlast bodies sometimes 3 or 4 times over. You know, it's not like an engine in a normal ICE vehicle that you're replacing once or twice in the lifetime of the vehicle. You're replacing the vehicle 3 or 4 times in the life of the battery in some cases.
Fair enough. Trina, I think there's a lot of questions come through, so I might maybe you want to get through that.
Yeah, definitely. Thank you so much, Steve. Thanks to all of our speakers. I'll start with some of the questions that came through first. Eric Isokungus asked the question, how are the current battery electric LHD offerings comparing to the diesel counterparts in terms of productivity? Does anyone want to quickly answer that one? Brian, Jonathan, Maarten, Olivia, anyone?
I'll take a stab at it. Our loaders are like 3 times more powerful than a conventional diesel machine. And we get pretty considerable tractive effort. We've got more weight. And so performance-wise, it's pretty remarkably improved. It doesn't take multiple attempts to fill a bucket. And you know, hauling up ramps is kind of ridiculous, and we can go like 20 kilometers an hour up ramp fully loaded with an 18-ton loader. There's a lot of improvement there.
I think this
It's
question
very similar to what we spoke.
Yeah.
Sorry, go ahead.
No, go Maarten.
That's exactly the same what we see as well. For example, with our boom trucks, going up ramp right now on 17% ramps, you see speeds of 14, 15 kilometers an hour going up ramp, which is significantly faster than a diesel equivalent. So I think that's a common denominator with all electric OEMs and products, or most of them anyways that I'm aware of.
Great. This question came through, I think, whilst Jonathan was speaking, and I know that Olivia touched on this as well. Chris Carr asked the question, have you looked at trolley assist for underground declines, Jonathan?
Yeah, we have. We've actually we've been running trolley assist underground probably since the early 70s. We've got a number of sites. There's a couple in Europe. Most of the trolley assist is actually in Canada. We've got a number of sites there, and we've actually got a team that actually dedicates on trolley assist, and the vehicles can be retrofitted. So it is technology that is available. Obviously, the decline has to suit because it's obviously, you know, you've got to have your cabling and your connectors to it. But yeah, no problems with that at all.
I love the fact that obviously the Chief Operating Officer of Pilbara Minerals, Dale Henderson, is online. Hi, Dale. He asked the question, and I'm not sure that anyone's answered this, but who are the leading OEMs for open pit electric powered haul equipment that do not require trolley assist? Do we have any one suggesting any OEMs there?
I know that Anglo American was doing a trial in South Africa, I believe, with hydrogen, and I can't quite remember. I thought it was Hitachi, but I'm not 100% sure. So,
okay. All right, we'll have to come back to you, Dale, on that one. Chris Carr also asked the question, how many, I think you answered this, Max. It was, how many EV light vehicles do you have operating underground currently? I think you said 400. Was that correct?
We have 400 plus four-wheel drive light vehicles. We will start phasing electric ones in from second half of next year. How much of the portion of that becomes electric, we're unsure yet, but it will become significant given the benefits that we're already seeing. And I should expand on that. Generally, if you're going to invest in an electric vehicle, regardless of the size, you want it to match or even exceed the operational cycles of a diesel, the equivalent or better. And in that sense, we are achieving that with our battery electric light vehicle because we charge it so quickly, we can recharge within a single, within the equivalent shift change time. So we're not talking about 8 to 10 hours of automotive style recharging. We're not talking about 4 to 5 hours of some OEM fast charges. We're talking about 50 minutes or less. Being able to do that retains your operational capability and minimizes downtime.
It looks like Michael Lewis picked up on your answer there, Maarten, and saying that the Anglo Hydrogen project in South Africa is equipping a Komatsu haul truck. So that must be the OEM there. It looks like, Olivia, you've answered Jade's question about the 40 to 45 point there. Did you have any thing to add on to that, Olivia?
Yeah, just that if you're going to invest in and you're relying on fast charging, you want your charger to be operating at its maximum capacity. So that's where temperature, particularly in a mining space, becomes critical. And I know that I'm bringing it back to a different industry a lot, but this equipment really has been designed for a different application in the beginning. That's where this equipment comes from, and bus charging generally happens at night, so where heat is not a problem. So it's a very different world in a mine, and you need to protect your equipment accordingly.
I think Joe Kakuza asked a question, to the panel generally. Do we know the proportion of the global mining industry that's actually implemented electrification, either wholly or partially, and electrification plus renewables? I know that Maarten answered that, it's quite a small proportion and everyone's got these goals to get to a certain point by 2030. I think Gonzalo was saying his mine site would like to go fully electric, but there's other goals of 2050. Is there any other stabs here, Michael, Do you know anything here?
I think that's beyond me on this one. I think it's more for the people who are actually making the toys.
Brian, any comment then from you?
I mean, I would say companies that are partially battery electric is in the dozens at this point. We've got, I'd have to guess, but on the order of 10 different mining customers around the world. And there's more that I think are doing light vehicle deployments to start. It's a little more rare to do haulage and loading equipment, but that's growing quickly. And I think everyone has accepted the reality that battery equipment is the future, and so everyone's making their plans, for when they're going to transition, and whether it's 2030, 2050, whatever it is. There's very few, I think, that are still holding on to a long-term diesel future, which is music to our ears. This is something that's been a long time coming, and it's time. I mentioned this, I think, a few years back. People have always started by asking the question, why go battery electric? And I think now people need to start asking the question, why would I use diesel?
I think too, when you're looking at a new mining project as a study manager, which I was for Newmont Goldcorp before, you kind of owe it to yourself and your company to at least consider going electric, and that's what we're seeing with a lot of customers right now, especially for new greenfield projects, whether they're in Indonesia or in Canada or in Australia. There's quite a bit of interest in at least exploring the topic. And once you start peeling back the layers of the onion, it's not difficult to find value in considering going electric. And that's what we're seeing more and more companies doing now. So it's exciting times. And on that front, I know the industry, at least in Canada, is very collaborative between mining companies. Mm-hmm. And I really benefited from that as sort of a study manager for Borden Mine in Ontario. And I love talking to other people as well to kind of talk about that journey that we went through, where you can realize savings or what to think about or how we manage certain things. So by all means, happy to reach or talk to anyone really.
Yeah, that's an important point. I think Jonathan and ABB was working on ABB worked with the Buenaventura mine site, and which is fully electric, but they did it in collaboration, I think, with a number of other companies. Obviously, Max's presentation brought in the Siemens perspective as well, and that collaboration on their performance results. And I think Gonzalo brought up the fact that they can't, obviously they've got this goal, Gonzalo, that you'd like to go fully electric, etc., but you need, you don't know how, and you need the partners, etc., to assist with that. So I think collaboration is definitely a key thing here. If anyone else wants to make that final comment or.
Yeah, I think from my perspective, that is a critical component. I guess the engagement across the industry is really important, and it's part of I think it was the last question you guys had on the panel last week from Ignacio. How do you get the engagement from the upper management, from the EXCO teams to go towards this and really start engaging in this sort of new phase of mining? It's difficult to sort of say, hey, you've got this full fleet of diesel trucks and boggers and everything, just change it and go to electric because it's going to be way better for you. So I think there's going to be a period where we've got this die-off of diesel, but there's a pickup of electric, and then there's going to be like a phase out, and you'll have that whole transition. And I guess that's a good thing because it gives us as an industry and OEMs particularly to sort of perfect the whole electrification of it, and sort of how do you incorporate the mine design to make it best for the electric stuff as opposed to the diesel. So there's all these things that we need to work in conjunction with each other in that total collaboration, not just with OEMs, but with OEMs and service providers and miners to sort of get that whole picture together.
Yeah. Definitely. On that note, I've gone 5 minutes over our scheduled time today, but obviously we had a lot of different perspectives, and I really do appreciate everyone's participation. Ignacio, Gonzalo, Brian and Maarten, thank you so much for returning back to the IMARC platform, and thank GMG obviously for their support in this. It's great to be able to take what we had last week and then transition that into a more interactive discussion this time. I did tell you there would probably be more questions and more interaction, so hopefully I haven't failed in that part. So thank you, gentlemen, for that. To our METS companies, Olivia, obviously from Siemens, Jonathan from ABB, Max from MacLean Engineering, and Steve from Safescape. Steve, the point that you made about batteries outlasting vehicles, I think that's going to be something that sticks in my mind for quite some time, because I find that quite interesting. I'd like to see how that compares to tyres, mining tyres, and where that sort of goes into play here as well. But thank you to all of you for taking part as well. Mining Plus, thank you, Michael Cockerill, for delivering those questions there. And obviously to our audience from everywhere around the world that we've got you today, thank you so much for joining us. I note that there are some attendees here from South 32, from Fortescue Metals Group, Rio Tinto, and the likes of some of the big mining houses, as well as some of the smaller ones here with us today. We've also got Caterpillar, I see on the quiet down low over there as well. So there's a number of different perspectives in our audience as well that are probably lapping up this information. We will make the presentations available to you, as well as this recording, so feel free to share, as well as connect with any of our speakers hereafter. Thank you again, and yeah, great to have everyone on board, and we'll either see you next week for our next episode, which is around mine closure and rehabilitation, or otherwise in 2021. Thank you, everyone.
Everyone, thank you.
Bye.